Now next topic is concept of electric potential difference. Now very simple, from the term only you can make out potential difference means it should be the potential difference of potential between 2 points. So just to consider this diagram, consider that current is flowing through the conductor from the point A to B, and let us assume that at the point A potential is VA and at the point B potential is VB. And as current is moving from A to B, so you can conclude that VA is greater than VB. Okay, so what is the potential difference? As I said, difference between the potential of 2 points. So simply you can write it as VA minus VB. Now, we have defined electric potential in terms of work done. I hope you can remember amount of work done to bring unit positive charge from infinity to a point. So, if you consider potential difference, it means it is the amount of work done to take unit positive charge from one point to other. Alright, now the question arises that you see I said one point to other, so one can take the charge A to B and one can take the charge B to A. Now the question is, are they same? No. Alright, so you have to know that from which point to which point you have to take the charge. So you see here, that's why I have written like this. When it is VA minus VB, then you will take the plus Q charge from B to A. You see what I have written? WBA. What does it mean? WBA is the work done to take plus Q charge from B to A. Alright, so this is the point you have to understand and remember. That when it is potential difference between A and B, in which direction you must take the charge? From B to A. You cannot take the charge from A to B. Alright. So, what is the definition of electric potential difference? Amount of work done to take, instead of writing unit positive charge, you can use the short form plus 1 coulomb charge from one point to other against the electric field. Against the electric field means it specifies that you have to take it from B to A, from lower potential to high potential. You have to take the plus Q charge. Then the amount of work done is known as the potential between the 2 points. Alright. Now, as the SI unit of electric potential is volt, so SI unit of potential difference, the short form potential difference PD is also volt. Alright, what is the SI unit of potential? It is also volt, VOLT. Alright, not VALT. The tail of L is connected. That's why it is looking like A. But it is O, VOLT. Okay, SI unit of potential is also volt. Clear? Now, how you can define 1 volt in terms of potential difference? Alright, that is also important. How one can define 1 volt in terms of electric potential difference? So you see, what is the definition of 1 volt in terms of potential difference? Again, it is important. For example, if 1 joule of work is done to take plus 1 coulomb charge from one point to other against the electric field, then potential difference between the 2 points is 1 volt. Alright, so you should learn the definition of 1 volt in terms of electric potential difference also. And this is the definition of 1 volt in terms of electric potential difference. Alright. Next concept is concept of resistance of a conductor. Alright. Now, before that you have to know what are the basic differences between conductors and insulator. From junior classes you are studying that. What is the basic difference? That conductors, they conduct electricity, insulators, they cannot conduct electricity. Alright. Conductors, why they conduct electricity? Because they are having free electrons. Alright. So you see, if you consider a piece of conductor, then inside the piece of conductor, who are there? Let us find out. So we know that inside the conductor free electrons are there. Now the question is arising that which electrons are free electrons? Are these electrons are free gift from God to the conductor? No. Okay, they are not the Diwali gift or any gift, free gift given by the God to the conductor. That's why they are free electron. No. Free electrons means what? From the atom, the outermost valence electrons, those who are loosely bound to the nucleus, they come out from the atom. Alright, so you see, if you consider any piece of conductor, so conductors are having atoms like this. Okay, now what is happening from every atom present? One electron or maybe 2 electrons, okay, outermost electron. I said which electrons? The outermost electrons which are loosely bound to the nucleus, they will come out. Okay, so you see, when electrons are coming out from the atom, then they become positively charged. I think you cannot see. Okay, I am making it bigger. So you see, from the atom, when electron has come out, then they will become positively charged ions. Alright, so this one positive written, they are the ions and they are immobile ions. What I said? They are immobile. Immobile means what? They cannot move from their position. Alright, they will be in their own position and they will vibrate about their main position. Okay, but electrons, these are the electrons, they are very naughty, they are just like you. They cannot sit at one place. So, what these electrons will do? Electrons will roam within the conductor. So, these electrons are the free electrons. Alright, so when you have not connected the conductor to any battery, then what is happening? Electrons are moving randomly. How the electrons are moving? You must note it down. Electrons are moving randomly within the conductor. That's why you are not getting any current. Alright, now when you are connecting it to a battery, then what will happen? Electrons are negatively charged particle. So I am just showing one electron. So electrons will move in this direction to the positive terminal of the battery. It will come and electron will move to the positive terminal of the battery. Then again through the negative terminal it will come out and it will move in a circular way. Okay. So it will give rise to the current. Clear? Now we know that is electric current. When electron moves on a closed path, closed circuit, then it gives rise to current. But we measure current as amount of positive charge flowing per second, and positive charge, it is related to the electron by the relation Q is equal to Ne, already discussed. Clear? Now you come to this point. When the electrons are moving like this, then these immobile ions, alright, they are quietly doing their work. What they are doing? They are vibrating about their main position. So you see, when the electrons will try to move within them, they will oppose their motion. Alright. So this opposition offered to the path of electron, or you can say the opposition offered to the flow of current by whom? By the immobile positive ions inside the conductor is known as the electric resistance. Alright. So how you can define resistance? The opposition or obstruction, okay, offered by whom? The immobile positive ions to whom? To the flow of current, or you can say flow of electrons also. Flow of electrons also is known as the electrical resistance. Alright. So you see, we have got the concept of electric charge, electric current, electric potential difference and electric resistance. Alright. Next is coming that factors on which resistance here of a conductor, I am writing resistance of a conductor depends. A very important topic, and means what I can say, favorite topic of the examiners also. So please concentrate on it. Now, factors on which resistance of a conductor depends. First is length of the conductor. Length, resistance, let us denote it by R. So here you see, the moment you will write like this, resistance within bracket R, then every time you don't have to use the word resistance, you can write R only. Length of the conductor. This is the first factor on which resistance depends. Now you see, from this concept it is clear, more will be the length, more will be the immobile ion present, isn't it? So more will be the opposition. So what you can say, if you increase the length, resistance will increase, and if you decrease the length, resistance will decrease, and you can write resistance is directly proportional to the length of the conductor. Alright, if you want to write in sentence, then you should write down R is directly proportional to length. Proportional to L I am writing, because it is understood L is length. Alright, then now next factor on which resistance of a conductor depends is cross-sectional area. Alright, means thickness. If you consider this is the thickness, then you see the thickness is more, but if you consider like this, the thickness is less. Okay, so it depends on cross-sectional area of the conductor. So you see, if you make the cross-sectional area bigger, then what will happen? The space between the immobile ion will be bigger and resistance will be less. So you can say that resistance is inversely proportional. So you see, I have written R proportional to 1 by A. Clear? 1 by A means what? You see, if you increase A, R will decrease. Then we say that R is inversely proportional to A. And this is symbolically, you can write R proportional to 1 by A. So resistance depends on the second factor is cross-sectional area of the conductor. The next factor is temperature of the conductor. Now for conductors, here there are 3 points. You must write it down separately. For conductors, okay, resistance increases with increase in temperature. Resistance increases with increase in temperature of the conductor. Alright. And there are certain things, means for carbon and semiconductors. Semiconductors means germanium and silicon. What are the semiconductors? The material which behave as insulator at low temperature, and if temperature increases at room temperature, it will behave like a conductor. So they are known as the semiconductors. And carbon and semiconductors. What are the carbon and semiconductors? Silicon and germanium. Okay. For them, what happened? This is very important. Resistance decreases with rising temperature or with increase in temperature. Alright. Then there are certain materials that they are known as constantine and manganese. Alright, resistance almost remain constant, with change in temperature. Means if you increase the temperature or if you decrease the temperature, then the change in resistance is so small that we can neglect. So we can say that resistance almost remain constant with change in temperature. Alright. So so far we have learned three factors on which resistance depends. First is the length, R directly proportional to L. Second is the area, R is inversely proportional to area, so R is proportional to 1 by A. Next one is temperature. For temperature there are three cases. For conductors, resistance increases with increase in temperature of the conductor and vice versa. But for carbon and semiconductors, what happened? Resistance decreases with increase in temperature, and for constantan and manganene, resistance almost remain constant with changing temperature. Then, now next factor on which resistance of the conductor depends is material of the conductor. Now, suppose you have taken copper as a conductor and you have taken aluminium as a conductor. Alright. Now, inside copper, the amount of free electron, concentration of free electron, and inside aluminium, concentration of free electrons are not same. Alright. If the concentration of free electrons is more, then what will happen? Resistance will be less. Clear? So you see, as different materials are having different amount of concentration of electrons, so different material, they offer different resistances. Alright. So you can write this way, that for different material, concentrations of free electrons are different, so they have different resistance. Alright. And conductors have generally low resistance and insulators have generally high resistance. Alright. So the material which is having more concentration of electron, then it will be able to give more amount of current, means it is having less resistance. Okay. So this is the general concept. So we have got the concept of electric resistance also and the factors on which electric resistance depends. Alright. So you see, we have got separately the concept of electric current, electric potential difference, electric resistance. Alright. Now we have to find out the relation between them, the connection between them. Alright. So how you can get the connection between all these terms we have learned till now from Ohm's law. Okay. So we have to know about Ohm's law. So what is the statement of the Ohm's law? Statement of the Ohm's law is, when the physical condition and temperature of a conductor remains the same. Okay. Now physical condition means what? Physical condition means length, cross-sectional area and material. Okay. I repeat, what is the meaning of physical conditions? Physical conditions means length, cross-sectional area and material. So you see, when length, cross-sectional area, material and temperature of a conductor remain same, means you are not changing them, then electric current flowing through the conductor is directly proportional to the potential difference between the ends of the conductor. So this is the statement. Now let us find out what is the meaning of the statement. Now you see, now before that we were not knowing about the resistance, so we have drawn the conductor like a straight line. Now as we know resistance, so a conductor generally drawn like this, means this is the resistance. Resistance symbol is this. This is the symbol of resistance, means it is the opposition. Alright, so this is the symbol of resistance. So resistance of a conductor is having always a resistance. So that's why we draw like this. So let us consider there is a conductor, and through the conductor I current is passing from the point A to B, whereas potential of the point A is VA, potential of the point B is VB. So let us consider V be the potential difference between A and B. Alright, and it is understood that VA greater than VB. You must draw entire thing, whatever I am writing here. Now you see, according to Ohm's law, this current and potential difference, they are directly proportional. So what you can write? According to Ohm's law, you can write this mathematically. Alright. According to the statement of Ohm's law, one can write V is proportional to I. So you see, V will be some constant into I, isn't it? This is the concept of maths, that when a proportional sign is replaced by an equal sign, then on the right side you have to introduce the constant of proportionality. So here you have to introduce the constant of proportionality. That constant of proportionality we denote it by capital R, and this is known as resistance of the conductor. Alright, so you see, resistance of the conductor physically, without any law, without any mathematical relation, we have introduced already. Now here we are introducing the concept mathematically by using Ohm's law. Alright, so V is equal to I into R. R is the constant of proportionality here, which is known as resistance of the conductor. Alright, so you see, according to this relation, one can write resistance is equal to V by I. V is the potential difference and I is the current. Okay, you know, here already I have written that V is equal to VA minus VB. So what does V represent here? V is the potential difference. So one can write what is the resistance potential difference by current. Now you must learn the statement of the Ohm's law and this mathematical relation also along with the diagram. So mathematically also you have got the concept of resistance. Next is coming, what is the SI unit of resistance? SI unit of resistance is Ohm. Alright, it is coming from the physicist name Ohm, and the symbol for it is this. This is omega, Greek letter. It is a Greek letter. You see how I am writing this way, then a loop and then this again. So, what is the SI unit of resistance? Ohm, and the symbol for Ohm is the Greek letter omega. Now, you see, according to this relation, R is equal to V by I. What you can write? 1 ohm is equal to 1 volt divided by 1 amp. So, 1 ohm, you can write it as 1 volt per amp. Clear? So, how you can define 1 ohm? If 1 amp current flows through a PD of 1 volt, then the resistance of the conductor is 1 ohm. Alright, very simple. You see, from this one only I am writing. How much current is flowing? 1 amp. And what is the potential difference? 1 volt. So, if 1 amp current flows through a PD of 1 volt, then the resistance of the conductor is 1 ohm. Alright, so SI unit of resistance and how much, how you can define ohm, that also you must learn. Clear? Now, according to Ohm's law, what you have got, that V is proportional to I. Okay, potential difference is proportional to current. So, according to Ohm's law, if you plot a graph between V versus I, alright, if you plot a graph between V versus I, it will be a straight line passing through the origin. Alright, so what is the nature of V versus I graph for a conductor? It is a straight line passing through the origin. Now let us find out what is the slope of V versus I graph. Alright, now you see, slope of V versus I graph will be change in delta V by change in I, isn't it? Change in the potential difference by change in current. I hope you can remember this, how to find out the potential of a point. You take 2 points A and B on the graph, then you draw perpendicular both the potential axis and the current axis. So suppose it is V2, V1, this is I1, I2. Alright, so if you join it, then this is representing V2 minus V1, this is representing I1, I2 minus I1. So if you consider C, then what is the slope of the graph? Slope of the graph is BC by AC, isn't it? Slope of the graph is tan theta. If you consider this is theta, this is also theta. So one can write what is the slope of a graph? Tan theta. So tan theta is BC by AC. BC by AC is del V by I. And you know, potential divided by current, what is that? Resistance. So this is the most important thing. Slope of V versus I graph is equal to resistance. Alright. So if one can find out what is the resistance, one wants to find out resistance, how you can find out? By finding the slope of a V versus I graph. Now here you see, suppose instead of plotting V versus I, you are plotting I versus V graph. Okay, means you are plotting I along y-axis and V along x-axis, and that should be done. Why? Because V is the independent one. Current depends on the potential difference. Alright. So if you plot it, then also you can say V proportional to I means reversely you can also say I proportional to V. So you see I versus V graph, it will also be a straight line passing through the origin. But in this case, what is happening? What is the slope of I versus V graph? I versus V graph, you see, according to our concept, it will be delta I by delta V, means 1 upon resistance. Alright. Now, 1 upon resistance is known as conductance. Alright. Resistance less, it will be able to conduct more electricity. So, from that concept, 1 upon resistance is known as conductance. Okay. So, this is the point also you must remember, although you may not get it in your board exam, but in any competitive exam, this is a favorite question. That instead of giving slope of V versus I graph, it will be asked what is the slope of I versus V graph. What is the slope of I versus V graph? It is reciprocal of resistance. That may be your correct answer. That may be one correct answer. Or you can write it as slope of I versus V graph is conductance. Now conductors again, or resistance, the conductors are having resistances, and those who are having resistance, we call them resistors. Okay. So resistors simply are different kind of name only. Actually they are the conductors only. You can say conductors also, you can say resistors also. Now depending on the behavior of the conductor, we can classify the conductors into two categories: ohmic conductors, ohmic resistors, or non-ohmic conductor or non-ohmic resistor. Very much interesting. Just see. Ohmic resistor means, from the name you can make out, they obey Ohm's law. Alright. So if it is asked, define ohmic resistors. So what are the ohmic resistors? The conductors which obey Ohm's law. They are known as the ohmic resistors. Alright. Now what are the examples? All metallic conductors, they obey the Ohm's law. Alright. Now if you consider the copper electrode in a copper sulfate solution in dilute H2SO4, they also obey Ohm's law. Just the electric cell I said, isn't it? They are obeying Ohm's law. So you can say that they are the ohmic resistors or ohmic conductors. So you see, for ohmic conductors, what you can say that V versus I graph is a straight line passing through the origin, and slope of the graph will give you, means the slope of the graph is equal to resistance. Alright, next is non-ohmic conductor. Now from the name only you can make out, and applying your common sense, if you have any, you can say what is non-ohmic resistor. Non-ohmic resistor means they do not obey Ohm's law. Is that clear? So they do not obey Ohm's law. So as they do not obey Ohm's law, so for them, if you draw the V versus I graph, instead of a straight line, it will be a curve. Alright, instead of a straight line, it will be a curve like this. It may be any kind of curve. For one Nanomic resistor, I am drawing it. It is a curve like this. Alright. So you see the resistance, in this case also slope will give you the resistance, but slope is changing at every point. So they are not having the constant resistance. Okay. That you have to understand. So if you want to find out the resistance at any point, then what you have to do? You should draw the tangent to that point, and then you should find out the slope of the tangent at any point. Okay. So you can say that for Nanomic resistor, they do not obey Ohm's law. First point. Second point, V versus I graph is not a straight line. It is a curve. Alright. Then the next point is the slope of tangent drawn at a point is the resistance at that point. Alright. So in this case, you cannot say that resistance remains same. Okay. It varies from one point to other. Now what are the examples of Nanomic resistor? That also you must know and remember. Electric cell, electric bulb, solar cell, then junction diode. Okay, these are all examples of non-ohmic resistors. Now you may get the question also, what are the differences between ohmic and non-ohmic resistor? Then you can write down 2 points. Alright, ohmic resistor, they obey Ohm's law. Non-ohmic resistor, they do not obey Ohm's law. For ohmic resistor, V versus I graph is a straight line passing through origin, whereas for non-ohmic resistor, V versus I graph is a curve. Alright, and this point is very important. An example of ohmic and non-ohmic resistors also you must learn and remember.